This is the second video on section 5.1, functions and level curves. And so, first of all, we're going to continue example 119 that we started in the first video. We'll start with part C. This time our function goes from R3 into R. So g of x, y, z is a square root of x squared plus y squared plus z squared. And our domain is all of R3. Why? Well, there aren't any numbers that we can't square. We can add these non-negative numbers together. When you add non-negative numbers together, you get a non-negative number, and we'll take the square root of that. So the domain is all of R3. The range, all the non-negative reals. This is a similar reason as part B. So if we want to get a positive number out, we can see fairly easily how to do that. We can also see how to get 0 out. Just substitute 0 for x, y, and z, and so g of 0, 0, 0 is 0. For a positive number, simply substitute its square root in for one of these and zeros for the others. For part D, h of x, y, z is x squared plus y squared plus z, all under the square root. This domain is not all of R3. What do we need? We need x squared plus y squared plus z to be non-negative. So x squared plus y squared plus z has to be greater than or equal to 0. X squared plus y squared is greater than or equal to negative z. Simply subtract z from both sides and write our domain as a set. So we have x, y, z in R3 such that x squared plus y squared is greater than or equal to negative z. Now, this necessitates that z be non-positive, right? So z has to be less than or equal to 0 in order for this to be true. I am not claiming that the domain are all the points in R3 where z is less than or equal to 0. I am claiming the domain is a subset of that set. So that's our domain. And our range, in a similar way to our previous examples, the range is going to be the interval 0 to infinity. In other words, the non-negative real numbers. So that concludes example 119. Example 120 is going to begin in this video and conclude in the next. So example 120, we're looking at level curves. I'm going to look at parts A through C in this video and the other 3 parts in the next video. So in all 3 of these parts, the function we're given, we have f of x is x squared plus y squared. So the first level curve we're looking at is k is equal to 1. So we have x squared plus y squared equal to 1. So what we have done is we've taken a cross section at z equal to 1. And when we do that, we see the unit circle. X squared plus y squared is 1. At z equal to 4, we see another circle. So we have x squared plus y squared equal to 4. That's a circle centered at 0, 0 of radius 2. What happens when k is 0? So we take a cross section at z equal to 0. We have x squared plus y squared equal to 0. We only have a point. So we have a single point that satisfies that. What does the graph of this function look like? Well, we take all of these cross sections and we have circles, except right here. What we have is a circular paraboloid. So when we take a cross section right here at k, we see x squared plus y squared equal to k. That's a circle centered at 0, 0 of radius square root of k. So that's what the graph of this function looks like. So think about the graph of a function of one variable. A graph of a function of one variable has 2 dimensions. You graph it in R2. So a graph of a function of 2 variables has 3 dimensions. We graph that in R3. So for, let's see, this is f of x, y, z. I'm sorry, I had a typo there. And I'm just going to fix that. So it is not f of x is x squared plus y squared. This should be f of xy is x squared plus y squared. So I'm hoping you're watching this video and not just the beginning, because if you saw the beginning, then all you're going to see is my little typo here. So we have f of xy is x squared plus y squared. But as I was saying, when you have a function of two variables, your graph is three-dimensional, because what your function does is it takes this point in R2 and assigns a number. And so with a graph of one variable, you have the point x, f of x, and you need R2 to graph that. Here, we have the point xy, f of xy, and you need to be in R3 to graph that. So your function takes a point, or it takes a pair, and assigns a number.